Welcome to AI Explains.
Hello.
Today we are doing a deep dive into a document that, and this isn't an exaggeration, literally defined the information age.
It really did.
It's Claude Shannon's 1948 paper, A Mathematical Theory of Communication.
We're talking about the bedrock. Before this paper, information was just a vague idea. Shannon comes along and turns it into actual physics.
Yeah, he proved you can measure it, like mass or energy.
Exactly.
And the wildest part of this whole blueprint, to even get there, Shannon had to ignore the one thing we all think communication is about.
The meaning.
The meaning. He just decided semantics are totally irrelevant.
Well, it's a necessary abstraction, For an engineer, it doesn't matter if you're declaring your love or just reading a grocery list.
Right.
Communication is just a game of selection. You're just picking one specific message out of a whole list of possibilities.
So it's like a giant multiple choice test. The content of the answer doesn't matter as much as just the act of choosing it.
That's a great way to put it. And to measure that choice, he needed a unit.
The bit.
The bit. A term suggested by J.W. Tukey. It stands for binary digit.
0 or 1.
The simplest possible choice. A coin flip. Shannon's genius was realizing that all information, no matter how complex it seems, just boils down to a series of these tiny yes or no choices.
So once he had that unit, the bit, he started to map out the whole system. He drew this simple diagram, stripping away all the specific engineering.
He didn't care about the device itself.
Nope. Just 5 abstract boxes, source, transmitter.
Channel, receiver, and destination.
And that abstraction is exactly why the paper is so timeless, right?
Absolutely. It doesn't matter if you're talking about smoke signals, a telegraph wire, or, a modern fiber optic cable. Mathematically, it's all just a channel.
A channel moving a signal from point A to point B.
Mm-hmm.
But of course, no channel is ever perfect.
Right.
There's always something getting in the way.
Right. And that's the villain of the story. Noise.
The static.
The static, the errors, the entropy that's always trying to corrupt the signal. Shannon's whole goal was figuring out the absolute mathematical limit. How much can you send before the noise just wins?
And to fight that noise, he did something incredible. He started analyzing the English language.
But not like a poet or a linguist.
No. He treated it like a stochastic process.
I love that term. It just means he looked at language as a statistical system. He wasn't asking about grammar rules. He was asking, what's the probability that the letter Q is followed by the letter U?
And he actually ran these experiments. He had a system try to generate English sentences just using those probabilities.
The results are, well, they're kind of terrifying. The math gets so close to sounding human.
Okay, listen to this. This is a sentence his math generated. The head and in frontal attack on an English writer, that the character of this point is therefore another method.
Wow. I mean, it parses grammatically. It feels like it should mean something.
But it doesn't. It's complete nonsense. But it proves his point.
That language is highly predictable.
Which brings us to, I think, the biggest aha moment in the entire paper, redundancy.
Mm-hmm.
Shannon calculated that English is about 50% redundant.
Which sounds like it's inefficient, right? But it's actually this brilliant defense mechanism.
It's the whole reason we can solve crossword puzzles.
Explain that.
Well, the words that cross over, they act as constraints. They're clues that let you guess the missing letters. If English was 100% efficient, every single letter would be a total surprise.
And a single typo would completely destroy the meaning of a word.
Exactly. That redundancy is the armor. It's the armor against the noise.
It lets your brain reconstruct the message, even if parts of it get corrupted.
So at the end of the day, Shannon taught us that information isn't some kind of magic. It's a physical thing. You can measure it, you can compress it, and you can protect it.
And he laid the groundwork for, everything. ZIP files, streaming video, all because he treated communication as a statistic instead of a conversation.
So here's a thought to leave you with. If our language is 50% redundant, if half of it is just sort of fluff to make sure we're understood, does that mean we're biologically wired to waste half our breath every time we speak, just to make sure we're heard?
It certainly changes how you think about a long meeting.
Thanks for listening to this deep dive. We'll catch you next time.